multiplying and dividing radical expressions. This has been a fun one. Radical expressions. So a radical expression is an algebraic expression containing at least one radical. So here's an example of a radical expression. Here's another example of a radical expression. We have a cube root and a square root. Even though they're not polynomials, you can multiply them using the same rules. Let's take a look. Simplify the square root of 7 plus the square root of 2 times the square root of 3 minus 6. So this kind of looks like a binomial, if it had variables, and since we're multiplying two term expressions, we can use the same rules that we would use for a polynomial. So if this was x plus 2 and x minus 6, we would use FOIL, and that is exactly what we're going to use with this one. So we have first, outside, inside, and last. Okay, and I went ahead and I wrote it out here so that way you can see where we can use the product property of radicals to simplify the expression. So I'm going to start with that first term. We can put them under the same radical. So 7 times 3 is 21. That will turn to the square root of 21. Second term stays the same. The third term, though, they're also being multiplied, two radicals multiplying, so I can keep them under the same radical and just do 2 times 3, the square root of 2 times 3. So let's see what that looks like. And I'm going to look at it briefly and see if there are any like radicals, any like terms, or anything I can do to simplify, and I cannot. That is the answer. It's as simple as it's going to get. I don't know, it's ugly. Let's look at another one. Let's look at, some steps. Follow the same rules that you would for multiplying binomials. That is step number 1. Step number 2, after multiplying, simplify radicals and combine like terms. So that's what we did in the previous example. Let's look at this example. I have the square root of 3 minus the square root of 2, quantity squared. So that whole thing is being squared, and it looks a lot like something we did in our last chapter, or maybe it was a chapter before. Well, whenever it was that one of the special products where we square the first term, then it's going to be minus 2 times first term times second term, then plus the second term squared. So you'll see what I'm talking about. Maybe this will look familiar. I have that first term squared minus 2 times the square root of 3 times square root of 2 plus the square root of 2 squared. So let's start simplifying. I'm looking at my first term and I see a square root and a square. These are inverse operations. They cancel. Boom. You're just left with 3. And I also see another one, that third term right there. It cancels and you're going to be left with 2. Now that middle term, that is where we have to remember to use the product property of radicals. I see 2 radicals, they're being multiplied together, which means since they have the same index, they're both square roots, I can say it's 2 times 3 under the same square root. And that 2 is going to stay on the outside. So this simplifies to 3 minus 2 times square root of 6 plus 2. Can I simplify this more? Absolutely. I have 3 over here and plus 2 over there. These are constant terms. I can add them together to make 5 minus 2 times the square root of 6. Let's look at dividing radicals. Your first step will be to place the dividend over the divisor to make it look like a fraction. Second step, multiply the numerator and the denominator by the conjugate of the denominator. So I'm going to pause for a minute right there and remind you of what a conjugate is. A conjugate is when you are multiplying by, it's going to look like itself, but you're going to change the sign. So if I had x plus 3 and I wanted to multiply it by the conjugate, I'm going to keep the first term x, change the sign, and make it a minus sign, and keep the second term 3. And when I multiply conjugates, I get a difference of squares. It's going to look like x squared minus something. Minus, I guess, 3 squared in this example, okay? But let's move forward and you'll see what I'm talking about. Our last step is to simplify. That should be a given by now. So it's already placed in fraction form, and now I need to multiply by the conjugate of the denominator. I have to multiply the numerator and the denominator by that. And the reason why I have it one on top of the other is because anything divided by itself is 1. And when I multiply by 1, I'm not changing the problem, I'm just changing how it looks. So the conjugate of 5 plus the square root of 3. Again, I said keep the first term, 5. Keep the second term, square root of 3. Since this is a plus sign, I'm going to change it to minus. And we're going to turn this into difference of squares. So I have 5 minus the square root of 3. Okay, and I'm multiplying top and bottom with that. For the numerator, I have to use FOIL. So I have first, outside, inside, and last. And our denominator, again, is a difference of squares since we're doing a product of conjugates. So first term squared minus the second term squared. So 5 squared is 25. The square root of 3 squared is just 3. So 25 minus 3 would be on the denominator. That numerator, I went ahead and multiplied them together. So if that was 4 times 5 is 20. We had 4 times negative square root of 3, so that's negative 4. Well, you see that there. And then plus 5 times the square root of 3 minus 3. And the reason why that is minus 3 is because it is the square root of 3 times the negative square root of 3. So those square roots cancel each other, and you're just left with negative 3. So do we have any like radicals? Yep, here we go. We have negative 4 plus 5 square root of 3. We also have 2 and negative 3. 20. Ugh, wow, I can't read. It is 20. So 20 minus 3 is 17, and if I have negative 4 radical 3's and I'm going to add 5, that just leaves me with 1 radical 3. 17 plus square root of 3 over 25 minus 3, which is just 22. So let's try one more. Okay, so we already have it in the form that we like it. It looks like a fraction. We have one on top of the other. Now we need to multiply by the conjugate. So feel free to pause the video, try this on your own, and play when you're ready to check your answer. So the conjugate of the denominator, we need to keep that first term. That first term is 2 times the square root of 3. Change that sign. So it was plus. I'm going to make it minus. And then I'm going to keep that second term, which is 5. So let's go ahead and set that up. Awesome. For the numerator, we're going to be using FOIL again. And for the denominator, it is a product of conjugates, which turns into a difference of squared. You're going to have the first term squared minus the second term squared. So let's take a look at how that is when we multiply together. And then we are going to simplify. Okay, on that numerator, I see that 2 times 3, that's the square root of 6. And in the denominator, well, let's take a look at that first term. I know what 5 squared is, right? That's just going to be minus 25 at the end. But this one right here, that squared is going to, well, if I were to write this out, it'd be 2 times the square root of 3 times 2 times the square root of 3. So that's really 2 squared. 2 squared times 3, what ends up being 3, because the square root of 3 squared is going to cancel each other, so it's just 3. And 2 squared is 4. 4 times 3 is 12. So we have 12 minus 25. And looking at that numerator again, I know it looks hideous, but it's as simplified as it's going to get. We can't do any more with that. And the denominator is going to be negative 13. Okay, hopefully that helped, and thanks for watching the video. Have a blessed day.